Hi class, this is Dr. Karsten, and I'm going to be going over the rest of problem set 13 from EngageNY, Module 5, Grade 4. I'm going to go over the rest of the problem set. I did a lesson on problem set 13 in a previous video, and in that one I had started problem number 1. And then I did problems 1, 2, and then 5A, C, and E in a second video. So you guys have all, I think, watched that. So I'm going to go ahead and do the rest of question 5 in this problem set with you, just because I feel like we could use a little extra work in this and you could use a little more support in how to do these. We will be moving on to lesson 14 next, because we did take a little extra time this week on 12 and 13. So let me do this so that you'll have this as a reference point. Now, I also just made a video that talks about tricks for comparing fractions that are less than 1, and a lot of these fractions are less than 1. So definitely take a look at that too, to just make you feel more comfortable with comparing fractions. And in that I do talk about when they have the same numerator, the same denominator, or when they're all mixed up and you have to use those benchmarks that we've been using. So with that little, or maybe not so little introduction, for which I apologize, let's jump right in. So for problem B, you can see here that both of these are fractions less than 1 because both of them have numerators that are smaller than their denominators. 5 is smaller than 12, 7 is less than 8. So let's go ahead and let's use benchmarks to work on this. Now, I know that I mentioned it to you before. For these problems, you're not really supposed to be using benchmarks. So let's do it first without using benchmarks, and then I'm going to model it with the benchmarks. So if I were to look at this, what I can see is that 7/8 is almost 1. It's just a little shy. It's 1/8 less than 1. And if I look at 5/12, I can see that 5/12 is actually less than 1/2. How did I do that? It was actually kind of easy. If I look at 7/8, I can see that 7/8 is really close to 8/8, and 8/8 is 1. If I look at 5/12, well, half of 12 is 6, so that would mean that's equivalent to 1/2. So that's telling me that 5/12 is 1/12 smaller than a half. So if he's less than a half, and this one is almost 1 whole, then I would go ahead and I would say that he is less than him. And if I were to write my reasons, and I am going to do the drawing for you in a second, I would say that 5/12 is less than 1/2, and I can say it's 1/12 less than a half, but this is fine. And I could say that 7/8, I'm going to say is almost, or is close to, or is about, I could even say because it's so close, is almost 1. Okay, so really quick, let's put these on, and this is 5B, and if I were to quick sketch this on a number line with my benchmarks, I'd have 0, 1/2, and 1, and that's not a negative, that's just a stray mark, sorry. So again, 5/12, and I explained it up here, that 5/12 is really close to 6/12, and I know that 6/12 is 1/2 because half of 12 is 6, so this would be 0, 0/12, this would be 12/12 because 12/12 is 1. When my numerator and denominator match, it makes 1. I cut it up into 12 pieces. I have all 12 pieces. It's one whole cake, so to speak. So when I'm looking at this, I can really easily see that 5/12 is very close to 6/12. It's just a little bit smaller. So maybe I want to put it right about there. And that's good enough for what we're doing right now. And then 7/8, similarly, I know this is 8/8. So I know that 7/8 is going to be really close to that. So if I'm doing my 8s, this would be about where 7/8 is. And so 7/8 is just a little bit less. So now you can see 7/8 is definitely bigger than 5/12. All right, let's take a look at problem D. So for problem D, we are comparing, again, two fractions that are less than 1. This one, it's 5/12, and then this one is 1/3. So I think for this one, most of you are going to do better if I go ahead and sketch it. Now I want to remind you that thirds cannot be divided nice and evenly in half. So again, this is D. Thirds are not easily divided in half. So if I were doing my number line, I have to remember that. Here I have 0, here I have 1 whole, and here I have a half. So if I'm doing my thirds, just to remind you, my thirds are going to fall about here and here. So I'd have 1/3, 2/3, 3/3, and I'm off frame. Sorry about that, gang. There we go. So I'd have 1/3, 2/3, 3/3. I'm actually just going to make this what we're looking at right now. So you can see that 1/3, 2/3, 3/3. So 1/3, and I think that was a number. I just want to make sure that I'm not. Oh, I have it right over here written down actually. Yep. So it's 1/3. So 1/3 is going to be right around here. Oop, 1/3. Oh my goodness, it's late and I'm tired. And that is such a mess. We're going to put it underneath. So there we go. It's 1/3. Now, if I were to try and figure out 5/12, let's think about that. So I'm trying to figure out where am I going to put 5/12 on this. Well, again, this is going to be 0/12. This is going to be 12/12. Now, if I want to turn my 12ths into a half, what's half of 12? 6. So I know 6/12 is equivalent to that. Well, 5/12 is actually going to be just 1/12 away from that. So now we have to ask ourselves, this is 1/3, that is 1/12, which one do you think is going to be closer? Well, 1/12 is a teeny weeny itty bitty little bit, so I know that 1/12, because that's really tiny, is actually going to be really, really close to 1/2. Those are very small pieces, those 12ths. Remember that. Compared to a third, definitely. So now what you can clearly see is that this is the larger, 1/12. Oh my goodness. I'm not starting this video over. Let me say that. Alright, because I don't think it's going to get any better. 5/12 is 1/12, which is why I wrote that, away from 1/2. And I was getting stuck on how small those 1/12 are. So anyway, 5/12 is here, 1/3 is here. Clearly 5/12 is actually going to be bigger because it's closer to the 1/2. So if I wanted to explain that, let's go back to this page. He's bigger than this one. And what I could say is, and this is going to be a longer explanation than you need to do, but I want it to be clear. Both are between 0 and 1/2, because remember we use our benchmark. We don't say the new fraction, the equivalent fraction, we always use the benchmark. Both are between 0 and 1/2, but 5/12 is closer to 1/2, which means it's bigger. Okay, I'm going to try not to keep doing these flubs, and let's try and focus. So, for F, we now have 5/4 and we have 7/8. This is such an easy one to do. I don't even have to draw it for you guys. I'm going to explain it super easy. So here we go. 5/4 is a fraction greater than 1. How do I know that? My numerator is greater than my denominator. So I'm just going to go ahead and write that. 5/4 is greater than, or more than would be fine, 1. 7/8 is a fraction less than 1. So 7/8 is less than 1. It's smaller than 1 because 7 is smaller than 8. It has not yet gotten to 1. Remember, 1 whole and 8 would be 8/8. It hasn't even gotten to that. But 5/4 is past 4/4. It's bigger than 4/4. So it's greater than 1. The numerator is bigger than the denominator. So clearly 5/4 is bigger than 7/8. All right, let's take a look at another one. So let's take a look at G. So G has 13/12 and 9/10. Can you guess how to do this one? Does this look kind of similar to F? It should. Here we have again a fraction greater than 1. So 13/12 is greater than 1. But 9/10, the numerator is smaller than the denominator. So 9/10, while being very close to 1, is also very clearly less than 1. And it's that simple. Look for these things when you're doing these problems. It makes it so much easier when you can see these things. All right, let's see if we have any nice... We have another one of those. How easy is that? H. Here we go, guys. I bet you know this. What is that one? It's 6/8. Is the numerator bigger or less than the denominator? 6 is definitely smaller than 8, so this is going to be less than 1. So 6/8 is less than 1. What about 5/4? Well, 5/4, 5 is greater than 4, so now I know that's a fraction greater than 1. 5/4 is greater than 1. So 5/4 wins. It's bigger. Or I guess it loses because the alligator's going to eat it, right? Okay, so I want to actually, just for that one, super quick, sketch it out. Because some of you might be like, oh my goodness, this is going way too fast. So let me just jot down 6/8 and 5/4. It's going to be a really, really quick sketch though. Okay, so really quick, I'm going to put in some benchmarks for us. I'm going to put 0, I'm going to put 1/2, I'm going to put 1, and yes, I know, I'm squishing them all down over into the side. The reason I'm doing that is that I have to go bigger. So this is 1.5, and this is 2. So if I'm looking at this, 6/8, if I turn some of these benchmarks into 8s, I would have 0/8, I would have 4/8 because 4 is half of 8, and I would have 8/8. So clearly 6/8 is going to be halfway between 4 and 8. 4 of this size pieces and 8 of this size pieces. And I'm being bad again, sorry. So this is where 6/8 would be. 5/4, however, remember what we've been doing where we've been taking one of these fractions and we've been pulling out the whole? So if I have 5/4, I can pull out 4/4 from that. And remember, this is just telling me the size of the piece. So this is saying I have 5 of these pieces, I'm putting 4 of those pieces over here, which means that I have 1 of those size pieces over here. 5 minus 4 is 1. So this is telling me that I really have 1 and then 1/4. So remember, we can just convert 4/4 into 1, and now I have a mixed number, 1 and 1/4. So if I wanted to do 1 and 1/4, what I could do, and this is a little tricky, I could say that this is 1 and 0/4. I can say that this is 1 and 2/4 because 2 is is half of 4. And I can say that this is 1 and 4/4, which is really 1 plus 1 or 2. But what I'm doing is I'm taking and I'm saying, well, I know I've gone this whole 1 already because there's a 1 in this number. I'm looking, this is equal to 1 and 1/4. Let me slide that down so you can at least see something. So I already know that this is 1 whole. So now I just need to figure out, am I going between 0 and 4, 0/4, 2/4, or 4/4 for this quarter? And clearly it's going to be here because it's between 0 and 2. So this is where that's going to land. So I have 6/8 here, and I have 1 and 1/4 there. So clearly 1 and 1/4 is bigger. But again, I did not have to go through all that trouble. That was a lot of work. I could have just said, hey, 6/8 is definitely less than 1 because my numerator is smaller than my denominator. 5/4 is definitely greater than 1 because my numerator is greater than my denominator. So I could have just written that and figured it out. All right, so with that said, though, let's do the last couple. So again, here, 8/12 is going to be less than 1. Oops, hold on, I just have to wiggle something. There we go. So 8/12 is less than 1, and fourths is, actually it's 2. So not only is it greater than 1, which I would accept as an answer, but it is equal to 2. How do I know that? Because if I had 8 fourths, I can pull out 1 4/4 out of it, so that's 1, and I can pull out another 4/4 out of it. So I can pull out 4/4 and then another 4/4, so that's 1, plus 1 is 2. So there you go, you can see it, sort of. It's kind of a mess down there. Okay, so with that said, we now know it goes like this. I'm running out of room here on my table because I have all my manipulatives hanging out with us. Okay, J. Last one, let's take a look. So for this one, we actually have to think a little bit more. We have to get into that number line a little bit. So we have 7/5, so clearly it's a fraction greater than 1. And we have 16/10, which also clearly is a fraction greater than 1. So we have to try and figure out where these are going to fall on our number line. So let me write them down for us. We have 7/8 and we have 16/10. So let's try breaking those down and see what we have going on here. And we can throw those on a number line. So if I look at 7/8 or 8/7? 7/5. Let's just move it on the other side. All right. See, I knew I was going to have one more mistake. Serves me right for working so late. Okay, so let's take that 7/5. I can pull 5/5 out, because that's 1 whole. So I'd had 7 of this size pieces, minus 5 of those pieces, is going to leave me 2 of those pieces. And you have to label those pieces, they're fifths. So 7 minus 5 is 2, and they're all fifths. This 5 is the same thing as saying 1. And this stays 2/5. So what I really also could say is that 7/5 is also known as 1 and 2/5. And you know how I love those fifths for fractions. I'm very excited we get to do fifths. Alright, so now we have tenths. Let me pull out 10/10, which is 1 whole. And then 16 minus 10 leaves me 6/10. So 16 of those size pieces minus 10 of those pieces leaves me 6 pieces. So that's going to leave me 1, because that's 1, and 6/10. Now, I don't know if any of you guys know how to reduce. I know that we have been decomposing and composing. I could actually compose that into fifths, and then you would see that I had 3/5. But if you don't see that, let's throw them on our number line and see what happens. So when we throw those on our number line, you know how much I love my fifths. I'm going to do a little cheat number line up here just to help us with those fifths. And the other thing that I am actually going to do, I'm contemplating rotating my paper sideways actually, is that I want us to have 0. In the book, they haven't been starting at 0 for these. So I'm going to have 0, 1/2, 1, 1.5, 2. Well, it's a little squished, but it's fine. So remember the 2/5. Remember how much I love my fifths? Because we have learned that when you put fifths on a number line, I'm just going to do 0 to 1. Oh, hang on. I'll be right back with you. Sorry about that. Okay, so when we put fifths on a number line, I know that I keep going back to this in like all my videos because I love the way fifths are on a number line. We have 1/5, 2/5, 3/5, 4/5. I know it's teeny weeny, and then over here is 5/5. And if I were to split those in half, remember the way that we always look at them is that 1/5 and 2/5 are between 0 and 1/2, because this is my 1/2 benchmark. They're between 0 and 1/2. This one's closer to 0, 2/5 is closer to 1/2. And then we remember that 3/5 and 4/5 fall between 1/2 and 1, with 3/5 being closer to the 1/2 and 4/5 being closer to the 1. You have to be able to describe them like that. So if I have 1 and then I have 2/5, look, 2/5 is going to fall close to the 1/2. It's not quite 1/2, but it's close to the 1/2. So I'm going to put it right there because it's going to be 1. So here I've hopped over 1 and then another 2/5. So this is taken care of here. This part falls between here, between the 1 and the 2, and it's going to fall right there. So I'm just going to put 1 2/5. I'm not going to put the fraction down. I don't want to make a big mess here right now. I want to try and keep it clean as possible. So now let's do 1 6/10. So again, we already know that we've gone that 1. What we have to do is figure out, where does 6/10 fall between here and here? So this would be 1 0/10. This would be 1 10/10, or 2. And here we're going to have 1, and then whatever's half of 10, which is 5. And that would be 1 1/2. Well, 6/10 is going to put me 1/10 to the right of that. So it's going to be like, we'll just put it there, and that's fine. It's probably even a little closer, but I don't want to get crammed. 1 6/10. And the reason I say that is that a 10th would put you closer to this than a 5th. But it's not a whole 5th, so I would have to work it all out. But anyway, it's too late for that. So I have my half here. So now if I were to describe this, I would say that 1 2/5 is a little less than 1 1/2, but 1 6/10 is a little bit more than a half. So he's bigger. So let's go ahead and let's take a look at where that falls right here. So where was I? Oh yeah, so 7/5, which we also know is 1 2/5. So 7/5, so that was 1 2/5, and that's right here, is a little less than a half. So, or 1 1/2 is less than 1 1/2, and we're going to say that 16/10. So remember, we figured out that 16/10 was 1 6/10. That's a little greater than 1 1/2. So is more than 1 1/2. So clearly 7/5 is larger. Wait, no, I just totally wrote that backwards, guys. Please don't copy me. Oh my goodness, because 16/10 is more than a half, so he's clearly the winner. Of course, I had to do that big mess up on the last problem. I'm sorry, but I do want to make sure I get these out to you, and I still have 3 other videos I have to make for Monday, and I want to make sure that they're all ready to go for you. I am going to post these over the weekend in case you want to look at these, but remember, we don't do anything over the weekend. Nothing's required. Go and have fun and enjoy the outdoors, but stay home and do that. All right. Have a great weekend, and I will see you all Monday in our Google Classroom. Have a good night, everyone.